Ladies and gentlemen, today we're going to be multiplying and dividing radicals. This is Chapter 12, Section 6 and Section 7. To multiply radicals, if you had something like A radical B times C radical D, you can multiply coefficients together. You can multiply radicands together. When you multiply the radicands together, the answer stays a radicand. You multiply the numbers underneath the radical sign, the answer will stay underneath the radical sign. So for our first example here, radical 2, radical 5, I multiply the 2 times 5 underneath the radical sign, and the answer is radical 10. If I can simplify the radical, I do, but 10 does not have any perfect squares that divide into it. For problem 2, multiply coefficients. The product of your coefficients will remain a coefficient. Multiply your radicands. The product of the radicands will remain a radicand. So you get 15 radical 12 here. Now, if it is possible to reduce the radical, you should. We can do that here. 12 is 4 times 3. This gives me 15 times 2 radical 3, which is 30 radical 3. Coefficients are 1, so there's no reason to bother multiplying them together. We multiply the radicands together. That product stays a radicand. So we get 18x squared. We break this up. Things you can take the square root of, 9x squared. What can't you take the square root of is the 2. 2 times 9 is 18. Take the square root. 3x radical 2. So you'll notice that after the multiplying is done, there's a really good chance you're going to have a simplifying radicals as well. So you'll have to do both things. We have radical 3, radical 12. Multiply the radicands together, it stays a radicand. That becomes radical 36, and that's a perfect square. So 6 is the answer. Here for problem 5, 3 radical 14 times radical 2. Coefficients get multiplied together. 3 times 1 is 3. 14 times 2 is 28, so you get 3 radical 28. 28 is divisible by 4, so that becomes 3 radical 4 radical 7, which is 3 times 2 radical 7, or 6 radical 7. Multiply the coefficients together, the product stays a coefficient. Multiply the radicands, the product stays a radicand, but you have to reduce that radical if possible. For problem 6, radical 5 times radical 5 is radical 25, and that's a perfect square, so take the square root of it. For problem 7, take the coefficients, 2 and 4, multiply them. Take the radicands, multiply them together. So you get 8 radical 36. 36 is a perfect square. That's 8 times 6, which is 48. Problem 8. Multiply the radicands together. 5 times 1 is 5. Multiply the radicands together. That product stays a radicand. It becomes 5 radical 9. The square root of 9 is 3, so that is 15. For number 9, you should rewrite this problem. 2 radical 3 squared. Remember, squared means multiplying something times itself. So we multiply 2 times 2. We multiply radical 3 times radical 3. 2 times 2 is 4. Radical 3 times radical 3 is radical 9. Take the square root and then multiply. Some of these steps you can skip, but the process all has to be there. Squaring a radical. These are opposites of each other. So you'll notice when we multiply this, if I do this kind of the long way, this gives me radical x squared. The square root of x squared is x. One of the ways you can do this kind of shorten up your work is realizing that when you square the square root, they're going to cancel each other out. So I would simply take this and cancel the squared and the square root and identify the answer as x a little bit more quickly. When you multiply a radical by itself, the radicals are going to disappear. The work you've done a couple of times. Radical 3 times radical 3 was radical 9, which gave you 3 in problem 8. Same thing in problem 9. You saw it in problem 7. When you multiplied radical 6 times radical 6, you got radical 36, which was 6. So that pattern is nothing new. You've seen it in a couple of problems. Alright, division is done the same way as multiplication. Instead of multiplying, we divide. So we do 9 divided by 3. We do radical 6 divided by 6. This is 3 radical 1, which is 3. For problem number 12 here, we do 8 divided by 2, radical 2 divided by 2. That gives me 4 radical 1, which is 4. 13, you divide the coefficients. So 8 divided by 4. You divide the radicands. 48 divided by 2 gives you 4 radical 24. We can now simplify this because 4 goes into 24. So it's 4 times 6. That gives you 4 times 2 radical 6, or 8 radical 6. For problem 14, switch colors here so you can see it a little bit better. We do radical 6x cubed over 2x. 6 divided by 2 is 3. X cubed divided by x is x squared. We split this up into what we can take the square root of and what we cannot. So we get x radical 3 is our answer here. Alright, last but not least for problem 15, well, not the last problem, but the last one before we get into some geometry here. If I take 25 and divide by 5, I'm going to take radical 24 and divide by 2. I get 5 radical 12, which is 5 times radical 4 radical 3. 5 times 2 radical 3 is 10 radical 3. Last but not least, 16. Which side is longer? Well, that's going to be a calculator exercise. So let me load the calculator up here while we do the first part. This part's always the worst. That little bit's got to load at the end. Takes forever. Find the area. Well, area is length times width. So I'm going to do 4 radical 3 times 3 radical 5. I'll multiply the 4 times the 3, multiply the 3 times the 5. 12 radical 15 is the area. Now it says which side is longer? Well, I have no idea. Let's take a look. Clear out what we have in there. 4 radical 3. Just do it on the calculator. 6.928, etc. 3 radical 5. 6.7. So 4 radical 3 is larger. So for which side is larger, I'm going to say 4 radical 3 for that. And we're done. I look forward to seeing you tomorrow. Please remember to bring your textbooks and your notebooks for class. Have a good evening.